take your copybooks, take your pen or pencil and begin your writing. The big theme that we start now, it is differential equations. Differential equations. And the first sub-theme, it is statement now of the problem the equation of motion of a body with resistance of the medium proportional to the velocity. The equation of a catenary. Let the function y is f of x reflect the quantitative aspect of some phenomena. Frequently, it is not possible to establish directly the type of dependence of y on x. But it is possible to give the relationship between x and y and the derivative of y with respect to x, y prime, y2 prime, etc. to nth derivative. That is, we are able to write a differential equation. From the relationship established between the variable x, y, and the derivative, it is required to determine the direct dependence of y on x. That is to find y is f of x. Or as we say, to integrate the differential equation. Integrate the differential equation. Let us consider two examples. Sorry. Example first. A body of mass m, maybe we write down is dropped from some height. It is required to establish that law according to with the velocity v with vary as the body falls. It is required to establish that law according to with the velocity v velocity v will vary as the body falls. If in addition to the force of gravity the body is acted upon by the decelerating force of the air. Anyone give the link from Gerasmina Makram Liat? He write about it. Accelerating force of the air, which is proportional to the velocity. Velocity. With constant is proportionality k. In other words, it is required to find V is f of t. Solution. By Newton's second law, m times dv over dt equals the force F, where dv over dt, the derivative of v with respect to t, is the acceleration of a moving body, the derivative of the velocity with respect to time. And F is the force acting of the body in the direction of motion. This force is the resultant of two forces. The force of gravity mg and the force of air resistance minus k times v. It is the force of gravity and it is the force of air resistance. Which has the minus sign, this sign, because it is in the opposite direction to that of the velocity. And so we have m times dv over dt equals mg minus kv. mg minus kv. This relation connects to unknown function v and its derivative dv over dt, which is a differential equation in the unknown function v. Differential equation in the unknown function v. To solve the differential equation is to find a function v is f of t, such that identically satisfies the given differential equation. There is an infinitude of such function. The student can easily verify that any function of the form, now I write down it, v is c times e to the power of minus k over m times t plus mg over k. Maybe this we denote 2, and this equation denote 1. The form v that we write down, this form, satisfies equation 1 no matter what the constant c is. Which one of these functions yields the sought for dependence of v on t? To find it, we take advantage of a supplementary condition. When the body was dropped, it was imparted an initial velocity v0, which may be 0 as a particle case. We assume this initial velocity to be known, but then the unknown function v is f of t must be such that when t is 0, when motion begins, the condition v is v0 is fulfilled. Substituting t is 0, v is v0 into formula 2. Sorry, not very good. This formula 2. We find v0 equals c times, if t is 0, e to the power minus chi over m times t e to the power of 0 is 1, because just c, plus mg over k. Whence c is v0 minus mg over k. Thus, the constant c is found, and the sought for dependence of v on c is v is v0 minus mg over k times e to the power of minus kc over m plus mg over k. Formula 3, not 2 prime. Just give a link from Gerasmira. He call and call all time. Continue. It will be noted that if K is 0, the I resistance is absent of negligibly small so that we can disregard it, then we have a result familiar from physics. V is V0 plus GT, 2 prime. This function satisfies the differential equation 1 and the initial condition V is V0 when T is 0. Examples second. Example second. A flexible homogeneous thread is suspended at two ends. Find the equation of the curve that is describes under its Allen wave find the equation of the curve that is describes under its own weight. It is the same as any suspended ropes, wires, chains, as for instance the caterpillar track of a tank between two supporting rollers. Solution. Let M0 with coordinates 0 and B be the lowest point of the thread. Now maybe I wrote it. It is y-axis. It is x-axis. In a line maybe with not very good, but it is point M0. M0. And let M be an arbitrary point, maybe here, point M, Y, O, X. Let us consider a part of the thread M0, M. This part, M0, M. This part is in equilibrium, the resultant of the force. The tension T not very good. Maybe I write down this way. This T. Good. It is T. Tension T. Acting along the tangent to the point E, m and forming an angle phi with the x-axis. Here, angle phi. It is the first force, tangent C. The second, the tangent H at M0. Tangent H. Acting horizontally. The third, the width of the thread gamma S acting vertically downward, where S is the length of the arc M0M and gamma is the linear specific width of the thread. Now I put it. Here, gamma S. S is the length of the arc M0M and gamma is the linear specific width of the thread. Breaking up the tangent C into horizontal and vertical component, it is vertical and it is horizontal component. We get the equation of equilibrium C times cosine of phi is C times cosine of phi is H and C times sine of phi is gamma S. Dividing the terms of the second equation by the corresponding terms of the first, we obtain tangent of phi equals gamma over H times S. Formula 3. Now suppose that the equation of the south for curve may be written in the form y is f of x, where f of x is an unknown function that has to be found. It will be noted that tangent of phi is f prime of x or dy over dx. Hence, dy over dx maybe only equals 1 over a times c. Formula 4, where the rational h over gamma is denoted in terms of a. Differential both sides of 4, formula 4. With respect to x, we find the second derivative of y with respect to x equals 1 over a times the first derivative of s with respect to x. Formula 5. But as we know, ds over dx equals square root of 1 plus dy over dx squared. It is derivative of the length of arc. Substituting this expression into equation 5, we get the differential equation of the south for curve d to y over dx double equals 1 over a times this square root. Formula 6. It expresses the relationship between the first and second derivatives of the unknown function y. Without going into the methods of solving the equations, we shall note that any function of the form y is a over 2 times e to the power plus x over a plus c first plus e to the power minus x over a plus c first, close the bracket, plus c second, formula 7, satisfies equation 6 for any values that c first and c second may assign. This is evident if we put the first and second derivatives of the given function into 6. We shall indicate without proof that this function for different c first and c second exhausts all possible solutions of equation 6. The graphs of all the functions thus obtained are called catenaries. Catenaries. Let us now find out how one should choose the constant C1 and C2 so as to obtain precisely that catenary whose lowest point M has coordinate 0 and B. The point M has these coordinates. Since for x is 0, the point of the catenary occupies the lowest possible position, the tangent horizontal. dy over dx equals 0. Also, it is given that at this point the ordinate is equal to b. Y is b. From 7 we find y prime equals 1 over 2 times bracket into bracket e to the power x over a plus c first minus e to the power of minus this value x over a plus c first, close bracket. Putting x is 0 here, we obtain 0 is 1 over 2 times e to the power of c first minus e to the power of minus c first. Hence, c first is 0, only 0. If the ordinate of the point M0 is b, then y is b. When x is 0. From equation 7 we get b is a over 2 times 1 plus 1 plus c second. Assuming x is 0 and c first is 0. Whence c second is b minus a. 1 plus 1 is 2, over 2 is 1, a plus c second is b, and c second is b minus a from this. Finally, we have y is a over 2 times e to the power of x over a plus e to the power of minus x over a plus b minus a. Equation 7 assumes a very simple form if we take the ordinate of m0 equal to a. Then the equation of the catenary is y is a over 2 times e to the power of x over a plus e to the power of minus x over a. Have you any question about this theme? Not question. In this case, we have
No
5-minute rest, and then we continue. Good?
Okay. Good, good.
5-minute rest. Next, subtitle. Definitions. Definitions. Definition first. A differential equation is one which connects an independent variable x, an unknown function y is f of x, and its derivatives y prime, y2 prime, 2 nth derivative of y into bracket. Symbolically, a differential equation might be written as follows: f of x, y, y prime, y2 prime, etc. The nth derivative of y equals 0, or f of x, y, dx, dy over dx, d2y over dx double, etc. to d nth y over dx and time equals 0. If the sought for function y is f of x is a function of one independent variable, then the differential equation is called ordinary. If one independent variable, the differential equation is called ordinary. Definition second. The order of a differential equation is the order of the highest derivative which appears. For example, the equation y prime minus 2xy second plus 5 equals 0 is an equation of the first order, because highest derivative of this expression, it is first derivative. And in this expression, we stay only first derivative of the function of y. The equation y2 prime plus ky prime minus by minus sine of x equals 0 is an equation of the second order, because highest derivative in this equation, the second derivative, y2 prime, y1 prime, 1 is lower than second derivative, etc. The equation considered in the preceding section in example 1 is an equation of the first order, in example 2 one of the second order. Definition 3. Third definition. Let maybe not. The solution or integral of a differential equation is any function y is f of x, which when put into the equation converts into an identity. Write down. The solution or integral solution or integral of a differential equation is any function y is f of x, which when put into the equation convert it into an identity. For example 1. Let there be an equation, the second derivative of y with respect to x plus y is 0. The functions y is sine of x, y is 2 cosine of x, y is 3 sine of x minus cosine of x, and in general function of the form y is c first times sine of x, y is c second times cosine of x, or y is c first times sine of x plus c second times cosine of x, are solutions of the given equation for any choice of constant c first and c second. This is evident if we put these functions into the equation. For example, if we take y is sine of x, then dy over dx will be cosine of x. The second derivative will be minus sine of x. And we have, after substitutions, the second derivative here and the function y here. We have minus sine of x plus sine of x equals 0. Identity. Example second example. Let us consider the equation y prime times x minus x squared minus y is 0. Here equals. Its solutions are all functions of the form y is x squared plus c times x. Plus c times x. Where c is any constant. Indeed, differentiating the function y is x squared plus cx, we find y prime here equals derivative of x squared is 2x plus derivative of c times x is c. Putting the expression for y and y prime into the initial equation, we get the identity. Y prime is 2x plus c, 2x plus c, times this x minus x squared minus y is x squared plus cx minus x squared minus cx. Calculate. It is 2x squared plus cx minus x squared 2 times minus cx. It is 0. Identity 0. Each of the equations considered in example 1 and 2 has an infinitude of solution. Not any question about this thing.
No, sir. No.
Not good. Now maybe I checked you and
Okay.
we continue after this. Now I open. No. The first group 2202. Abazer Saldin Bashir Saleh. Here or not? Not. Abel Sud Abdurrahman Ahmed Fahmi. Here?
Yes, I'm here.
Good. Abu Lela Saad Ali Shekhata. Not? Ali, Abdallah, Mohammed, Khalil.
Yes, I'm here.
Yeah, good. Al-Hasnawi, Hussein, Amir, Musa. Not. Al-Furaiji, Yusuf.
Yes.
Al-Furaiji.
Teacher, الفريجي عند الخسراوي حسين.
Yes, I check you. Atta
الخسراوي yes.
Mohammed El Sayed Mahmoud Mohammed. Atta Mohammed here? Not. Badvi Abdurrahman Ali Hagat. Here or not? Badvi.
Yes, but he is here.
Al-Furaij, I can see that you here, but we sleep. Why he don't say that he here? Bin Said Ramzi Rauf, here or not? Not? Bid Majlisrei Hussein Saad Sachit.
Yes, I'm here.
Yeah, good. Grace Bishoy Adel Mikhael. Here? I don't hear you. Grace. Sleep? Gusay Kamal Nuraldaim Il-Bashir. Not? Not. Janain Ayub. Not? Yepes Banilya Brian Fernanda. Yepes, right. Good.
Garasmina. Are you say Garasmina?
No. Garasmina in other group. Now.
Yeah, but I will be with group. Yeah, I will be with group 2102 because I'm in Russia.
Good.
And
you don't
and I want
my list. Because
please add me just please just add me in list 2102 because I live in Russia. I'm now in Russia, in Russia, and I will be with them in the university because that my timetable will be different. So please get me in group 2102.
Good, I understand you. Next, Luawat Suleiman Ibrahim here.
Yes, I'm here.
Yes, good. Adel Jefferson Sabiti. Good. Amir Gamaldin Hussein Yedris. Not. Atman Tariq Khalid Klifa. Not. Fuat Mohammed Tahan. Not. Haider Diyar Malik Haider. Not. Hassan Assama Haysam Resk Mohammed. Here. Hassan Assama. Sleep?
Yes, I'm here.
You here. Good. Hussein Hassam Ahmed Elaiva.
You checked me, Hassan Osama?
Yes, I'm here. Hussein.
Hussein here.
Yes, I'm here.
Elgal Hazem Anwar Ibrahim. Here or not? Elgal Hazem. Elgal Hazem. Not? Grace Bishoy. I can see your message. Elgal, not? Yahya Faisal Hassan Yusuf. Not, yes. I save it. And next group 2204. Abdurrahim Ahmed Mahtar here. Abdurrahim. Not? Ali Abaidi. What?
Hassan Osama, you checked me?
Who? Hassan Assama?
Yes.
Hassan Assama. Yes, I checked you.
Okay, thanks.
Next. Alabaidi Mahanat Abdurrahim Hantish.
Yes, I am here.
Ali Mahmud Marwan Mahmud Genidi. Not? Alami Hussein Allah Abdul Al Hussein.
Yes.
Alami here. Al Salim Musab Muayyad Hamid. Al Salim. Not? Garasmina. Garasmina here. Yes. Garasmina. Dirak Karim Ali Mahmud.
Yes.
Good, Garas. Dirak. Not? Ilnuvihi. Il Sayed. Not? Zabar Abdurrahman Abdulassam Zabar.
Yes.
Here. Mansur Mohammed Ibrahim Rabim. Not? Sultan Amar Ibrahim Al Sayed. Not? El Gandhi. Not El Gandhi. Yes, I create a segment right now. Good. I checked you. Now I will create a segment and then we end it. One minute, please. Now 3. Good. I create assessment. Can you see? You must send me your lectures to 5 o'clock today. Understand me?
I
No.
can go.
Okay.
What go?
Can I go?
Yes, you can. We.
Can you repeat,
Okay.
please?
Goodbye. Please send us the lectures in YouTube. Please.
On YouTube, yes, I sent it.
Okay. Thank you so much.
I sent on YouTube. Any question exist?